Okay, good evening, everybody. This is Ravi. I'm back with the second installment of our electricity topic. Our first part I have taken on Friday evening. There is a recording on YouTube. You can please, those who are new to this channel, new watching me for the first time, please go ahead and watch that first. In our first topic, we covered Ohm's law, electricity, potential difference in depth, and we did few problems over there also. That were resistance in series, resistance in parallel, and all those things. Okay, so let me introduce myself once again for the newcomers. And my name is Ravi and I'm your master teacher. I'll be taking physics, class 10, CBSE board exams. As we know, board exams is just couple of months away. So I hope your preparation, I'm sure your preparation would be really good right now. If it is not, then start bucking up now. Okay. Now, this is the second installment, as I said. So let's begin. This is the chapter we are taking, the electricity, CBSE Physics Lecture 2. All right. So let's begin. Okay. So about me, I've just told you about it. Okay. So in my last slide, in my last lecture, I put an emphasis on this particular slide, which tells you about this chapter. This is like this graphic tells you about how this chapter would proceed. There is this is your resistance, which is given in ohms. All of you can see this is your resistance, this is your voltage, and this is the current. Okay, so the job of resistance is to stop the current, the job of voltage is to push the current. This is what happens in entire chapter. So we have explained this in depth in our last class. Now I'm taking it further. All right, so let's go. All right, so today topic mostly we will be focusing on electric power. We'll be focusing on heating effect of current. It means when a current passes through a circuit, the heat produces. We will be calculating that, all the formulas, all the numericals and all. And after that, we'll be taking a lot of numericals, lot of problems today, which has come in past years, that is PYQs, and some NCERT numerical also. And we'll wrap up the class with that. So that's going to be the end of the class today. So please be with me for next 1 hour and enjoy this. Understand what we are doing, enjoy this, and I'm sure you will surely love it. Good evening, everybody. Once again, whosoever just joined, my name is Ravi, and let's begin. Okay, so electric power. So when we talk about electric power, okay, see, electric power question comes in exam as small, like in your short answer question, maybe there will be a part of this which you have to understand this. It is the rate at which the electric current is used. This is the definition of it. The formula of electric power, that is power, is nothing but VI. So how would you remember it? It's simply the way we remember it, it is like VIP. We call it VIP. If you remember VIP, V mean voltage, I mean current, P is power. So just put is equal to in the middle and you will be able to remember this VIP. Okay, this is how you remember this. So power is equal to V into I, voltage into current, or I square R. Now from this formula where is come? So we know that from Ohm's law, V is equal to IR. Right? So just replace V as IR. So you get power is equal to IR into R. So this comes out to be I into R square. This is the second formula for power. So there are three formulas for power you need to remember. All three are important and will be used in different cases that I'll be explaining you how and where. Alright, so first formula is VIP. Second formula is P is equal to I square, IR square. And third formula is, over here we can just replace I with V by R. So our formula becomes P is equal to V square by R. So these three formulas for power are very, very important for your board exams. There are a lot of numerical comes on power. Please understand, please, I'll explain you everything. We'll do a lot of problems on it. But as of now, please note down these three formulas. VIP, V square by R, I square R. That's it. Alright. So let's go ahead and understand the further part. Okay, the SI unit of power. SI unit of power is watt. What is the SI unit of power? Okay. 1 watt, this is the definition of 1 watt. 1 watt is the power when 1 ampere of current flows through a potential difference of 1 volt. And this is, again, this is also important. 1000 watt is also called 1 kilowatt. 1 kilowatt hour is this. Sometimes the question comes is, okay, what is 1 kilowatt hour? 1 kilowatt, when we say kilowatt, is power. When we say kilowatt hour, is energy. I'll discuss that in a minute. I hope you're able to understand me. I hope you're able to follow me. Please be with me till the end of the class, and you will pick up a lot of concepts from here. Okay, let's go ahead and go to the second slide. That is going to be your heating effect of current. That means whenever a current, okay, you might have seen that in your refrigerator, TV, anywhere, wherever the current passes, you find that refrigerator and all, they just heats up. We are here to find how it, how to calculate that heat. Okay, there is a formula for that. So first, if a current I flows through a resistor of resistance, okay, and R, and with the time which charge Q flows through, then the work done is good. So and so, all these things given. All you have to remember is heat is nothing but power multiplied by time. So whatever power come, multiply by time. And what the formulas of power, what we had? VIP first, right? So I can write VI into time. So this is my first formula. Or I can write VIT. Second formula I can write I square R into time. And third formula I can write V square by R into time. I'll explain you where these formulas are used. I'll explain you in a minute. So please note down these formulas. Understand these formulas. It's nothing but whatever power is given to us, we multiply that with time and we get heat. This is how we calculate it. There are direct questions which comes in exam. Direct question on these formulas. So please be with me. Understand everything. We'll do a lot of formula, lot of numericals today. And this is how we're going to proceed. Now, the unit part. Unit of heat is joule. It is joule. Okay. But you will come across, there is a thing called kilowatt hour. Okay. So kilowatt hour, now there are two things which comes. One is kilowatt and one is kilowatt hour. A lot of students have issues in that understanding of it. What is kilowatt hour, sir? What is kilowatt? What is the difference between them? Okay, so kilowatt hour, 1 second. Let me just write it. So kilowatt hour. Okay, I wrote KHW. No, it's not like that. It's called kilowatt hour. So this is the unit of power. This is the unit of energy. So how do we do it? Energy is equal to nothing but power into time. So if I take power, which is kilowatt, this is the part which is power, and this is the part which is R. R means time. So power into time. So whenever the power is given to us, we multiply with that with time and we get kilowatt hour. We'll understand it further. Okay, as we go ahead, we understand it further. All right. Yes. Explain again. Sure, I can explain you again. Okay, I can go back over here. You see over here. Okay, I started with electric power. Electric power is, these are the three formulas for electric power you need to understand. First formula is VIP. Just how to remember it? I'm just telling you, VIP. Just put a is equal to over here, P is equal to VI. V is voltage, I is current, P is VIP. Second formula is I R square. Third formula is V square by R. And second, we came across this particular heat. Heat is equal to power into time. These are the formulas for heat. We can just replace power with VI, I square R, V square R. These formulas, you will have direct questions, direct numericals coming in exam on this. I hope it is absolutely clear, right? Yeah, many students come to me, by the way, guys. I want to discuss something about you. Many students come to me and they ask me, okay, sir, only 2 months remaining. Our preparation is not very good. How to go about it? Or maybe they are not confident how to go about it. So I'm telling you guys, at the last moment, what you should do, you don't have to do a lot. Just take NCERT. Your first book is NCERT. Take NCERT, do all the examples in NCERT, and end of the day or end of the chapter questions in NCERT. Is good enough. Second thing you need to do is pick up past 10 to 15 years of CBSE papers. Pick up past 10 to 15 years of PYQ, past year questions, and just do that. 90% of the paper will be from that. 90% of the paper. Okay, you may have different numerical values, but the formulas used will be the same. So this is how you should prepare at your last moment. It can be done. There's no problem. In fact, a lot of people start. Even I also did like that. I also started in the end. Okay, ended up scoring pretty well. All right. So you guys also can do that. It's not a problem. You start now. Do PYQs. Do the end of the chapter questions, and there we go. That's the end of it. Okay, so let's get back to our topic over here. Okay, before going further, guys, I want to introduce you something called monkey problem. Okay, monkey problem, which will be used in solving the numericals. Okay, so let's say if 30 let's say 30 monkeys eat, let's say 90 bananas. Okay, 10 monkeys will eat how many bananas? This is a question. I know everybody can answer this, but trust me, if you can answer this, you can solve any problem, any numerical problem over there. If you can answer this, how is it? Let me tell you this. So how to do it? 10. Okay, first we calculate one monkey. One monkey will do 90 by 30 banana, right? And 10 monkeys will do 90 by 30 into 10. Here we go. We can cancel this. It comes out to be 30 bananas. This is how you will calculate this particular thing. Now let's go and hit the problem, and let's see. We will use this monkey problem over there, guys. Okay, you will use this monkey problem. What kind? How is it used? This will be given as in 1 hour power consumption is 30 kilowatt. In 8 hours, what will be my power consumption? We have to just calculate that. Same like monkey problem. If you see the question comes. Okay, what kind of more question comes? In 24 hours, your power consumption is, let's say, 100 kilowatt. In 3 hours will be how much? This kind of question actually comes in exam. This kind of question, I'm just giving you a hint. You know, this is the kind of question which comes in your numericals. So please be with me. We are covering few numericals over here now. Please be with me. Power, heating effect of current, Ohm's law, everything will be mixed now. We are starting questions now. All right. So let's see how it goes further. So first MCQs. All right. On your screen you have a question. This is a past year problem, which is an electric iron draws a current of 4 ampere when connected to a 220 mains. Its resistance must be. Come on, I give you a few seconds to solve this problem. Let's see how if you can do it. Go for it. Yeah. What formula are we going to use over here? What formula are we going to use? If you see, he is asking us to find out the resistance. What is given to us? Resistance we need to find. This is how you should do the problem, guys. Okay, you need to, okay, first thing you need to write what you have to find. Second thing is what is given to you. What is given to you? Given to us is current is 4 ampere. Current is 4 ampere. This is given. Voltage is 220 volt. We know that there is something called Ohm's law. Yes. Okay, so I got this answer. People have started writing answers. Okay, yes, absolutely correct. I can see the comment box. People have writing answers, and that answer is absolutely correct. It is 55. How to get it? Simply use Ohm's law. What does Ohm's law says? V is equal to IR. So we have to find resistance. So I can write R is equal to V by I. V is what? 220. I by I is nothing but 4. You multiply this, you get 55. And do not forget to write this unit. Otherwise, your marks will be deducted in your board exam. Please, units are extremely important. Units are extremely important. Please remember to write the units. Okay? Yes. All right. So 55 ohm is the answer over here. All right. Perfect. Very nice. Okay, let's do the next problem. Let's go to the next problem. Yes. All right. Yes. Absolutely correct. 55 ohms. All right. So let's go with the next problem. Okay. What does the next problem say? Okay. Next problem is from the potentiometer. The potentiometer is considered a versatile and accurate device. Actually, it is to make an electrical measurement of EMF. So it is used to measure the EMF. Okay. Why? What is the reason behind that? There are 4 answer choices. Meter, right? Because the method involves a combination, there are cells involved because of potential gradient. What is the reason behind that? Let's see if somebody can answer. Come on, answer me in the comment box. Everybody, all the aspirants, all the warriors, all the soldiers who are going for 2 months later. Come on, I need everybody, answers from everybody. Come on, go ahead. All right. Yes, I can see. Yes, come on. All right. So the answer to this is, there is, correct, absolutely correct, as there is no flow of current through the galvanometer. So since there is no flow of current through the galvanometer, all the current passes through the circuit and we can measure it correctly. Okay, so this is the potentiometer. As you go further, 11th standard, 12th standard, you have, if you take science, which I hope you do, because if you take science, I'll be teaching you over here, right? So if you take science, you will come across electricity chapter over there. You will study everything in depth, all these things, how it happens, what it happens. As of now, please remember this, because this is a very important MCQ for the CBSE point of view. Potentiometer is a very important topic, guys. Okay, potentiometer, please understand this part. Let's do the next part, next question. Okay, let's see. Okay, this question is based on ammeter. Okay, let's look at the question. What does it say? You are given 4 ammeters, A, B, C and D. All right, okay, and D over here. There is one fourth one having least count mentioned. So ammeter A with least count is this much. Okay, what is the meaning of least count? Least count means the least amount of measurement it can do. Okay, least amount of measurement it can do, that's called here least count. So ammeter has a least count of 0.25. It means it cannot measure less than 0.25. Ammeter B has a least count of 0.5. That means it cannot measure less than 0.5 amps. Ammeter C is least count of 0.05. Ammeter D is least count of 0.1 ampere. Now question is, which of the ammeter would you prefer for doing an experiment to determine the equivalent resistance of two resistance most accurately when connected in parallel? Yes, come on. Yes, please. Yes, you are correct, absolutely. Naveen, I can see you are correct. Yeah, all right. So the answer to this particular, yes, I'm waiting for the comment box. Come on guys, come on, buckle up, everybody, go for it. Yes, all right. So the question is in front of your screen, which ammeter will be used to determine the equivalent resistance most accurately? Okay, so the answer of this is, yes, I'm waiting for the comment. All right, so the answer over here is the one which has the minimum least count. So whichever has the minimum least count, LC is least count, minimum least count, whichever ammeter has minimum least count will be used. So here if I see the least count is minimum in case of C, 0.05, rest all are bigger than C. So the answer over here is ammeter C. Okay, I hope it is clear to everybody. Yes, these are the very important question, guys, very important question on least count, question on potentiometer, question on Ohm's law, question on power, heat. We'll be doing all those questions as we go further. Okay, yes, yeah, yes, I can see lot of people have answered correctly. Answer is D, that is ammeter C. Okay, now let's go with next question. Next question on your screen is coming up. All right, this is the next problem. It says, when a 4 ohm resistor is connected across the terminals of a 2-volt battery, the number of coulombs passing through the resistor per second. Number of coulombs, whenever we say number of coulombs, it means it's asking about amount of charge. How much is the charge passing through per second? So number of coulombs per second, we want to, so charge is Q per second. This is also same as asking about current. Remember this, that's why you have used this particular thing, coulombs passing through per second. Sometime examiner likes to make you disoriented. He'll see, okay, Some students say, oh my God, I don't remember this formula. No, you know it already. He's asking you current. He's asking the current, nothing else. So your job is just focus. So he's asking the current. Number of Q by time is nothing but current. All right. So again, resistor is given to us, resistance is given to us, battery 2 volt is given to us. What formula are we going to use? Ohm's law? Yes, Ohm's law. So what is the formula of Ohm's law? V is equal to I into R. Ohm's law. Now we have to calculate I. V is given to us, R is given to us. You see, R is in ohms, V is in 2 volt. So I can just put it over here. So what's the answer? What's the answer? Come on in comment box, everybody. Yes, I'm waiting for your answer. Kar do yaar, come on. Yes. Okay. Yeah, I can see. Yes. Okay, fine. So the answer here over here is 2. Absolutely correct. I can see a lot of people are writing the right answer. So 2 by 4 is equal to I. Answer will be in ampere. Remember, okay? So this is 1 by 2, 0.5. So you have your answer as 0.5. It's pretty simple, pretty clear. This is the kind of question which comes in exam, guys. Okay, yes, answer is B. I can see a lot of you guys have given the right answer. Very good. Keep it up. Keep it up. All right. Keep it up. Okay, so let's do our next problem. Let's go for the next problem, shall we? Yes. Next problem is, all right. Let's see, this is the next problem. The next problem says, okay. So the next problem says, an electrical appliance has a resistance of 25 ohm. You see, resistance is given to us. When this electrical appliance is connected to 230 supply line, the current passes through. Again, this is again a problem. This is a past year problem, guys. All the problem we are taking are past year problem, and as you can see, Ohm's law is getting repeated over and over again. So Ohm's law is very important for these MCQ type problem, 1 mark question, 2 marks question, which comes later on also. You will find these Ohm's law is very important. So V is equal to IR relationship. You can use it over here also and get the answer. All right. So what's your answer? Okay, voltage is given to you, resistance is given to you, current you have to find out. So what's your answer over here? So again, V is equal to IR. I'm leaving up to you. I'm leaving up to you. Okay, I hope everybody can find the answer. Oh yes, I can see the comment box. Everybody is writing. Lot of you have given the right answer. Very good, guys. So you are trained in Ohm's law now. Okay, you are trained in Ohm's law. I can see 9.2. Lot of people I can see in comment box. We have Dhanush, Shreya, and Tanush. Lot of you have given the right answer. Very good, guys. Keep it up. Okay, let's go and do the next problem. Okay, let's go to the next problem. Let's see. All right. So, excuse me, guys. The purpose of rheostat. Okay, what is a rheostat? This question actually comes in exam. What is a rheostat? What is a rheostat? Rheostat is basically a resistance where a variable resistance. A thing with variable resistance. It means a resistance will be there. On top we will have a jockey, a key. And as we move the key here and there, the resistance changes. So we can increase the resistance or we can decrease the resistance. Using the rheostat, we can, this entire thing is called rheostat, guys, in which there will be a resistance and there will be a jockey. So there will be actually a knob. You just move the knob, this jockey moves here and there and it changes the resistance. Using this, we can control the flow of current. All right. So now question is, the purpose of rheostat. What is the purpose of rheostat? Increases the magnitude of current, decreases the magnitude of current only, increase or decrease the magnitude of current, and none of this. Okay, comment box. I need answers, everybody. Yes, I need answer from everybody. Come on, comment box. Go for it. Okay. Yes. All right. I can see answer is C. Yes. Lot of you are giving us absolutely correct answer. It increases or decreases the magnitude of current. It controls the current. We can increase the resistance or decrease the resistance. So if we increase the resistance, current will decrease. If we decrease the resistance, current will increase. Why? Because we know that V is equal to IR and R is equal to V by I, or R is proportional to 1 by I. It means if current is more, resistance is less. Resistance is more, current is less. All right. This is how it is done. Let's go to the next problem now. I hope it is clear. Yes, I can see a lot of answers. Very good, guys. Excellent. Excellent. You guys are doing a great job. Just be with me. Okay, let's go further. Let's go some more questions. Now let's do short answer questions. Shall we? Okay. Shall we? All right. Before that, I like to do one problem from NCERT. Okay. From NCERT, I like this problem. All right. So the question in NCERT, that is example number 11.11. You can see the NCERT over there. Okay. Okay. The question says that 100 joule of heat is produced. So heat produces 100 joule. 100 joule of heat is produced each second in a 4 ohm resistance. Okay. So resistance is given as 100 each second, this much in each second. Writing here. Okay. Resistance given is 4 ohm. All right. Resistance given is 4 ohm. And what is he asking us? He's asking us what is the potential difference. Okay. This is example number 11.11, guys, from NCERT. 11.11. This is the example number. You can have a look. Very important example. That's why I'm taking this. Okay. So what is it saying? It's saying find the voltage. V is equal to question. Okay. And per second means time here given is 1 second. Now we need to find what is the voltage. Okay. So potential voltage is asked from us. How to find the voltage? If you see over here, yes. Initially I told you about the formula. Yeah. Initially we know that we can use the formula V square by R is equal to heat, right? And using that we can find the voltage. So V square by R, remember, into T is my heat. Now T is given as 1 second. As you can see, T is 1 second. R is given as 4 ohm. So I can write V square is equal to heat H multiplied by R divided by time. Or V is equal to square root of H into R by time. So just use it and you can easily solve the problem, right? So this is how you will be solving this problem. All right, guys. Yes. Okay. I'm leaving calculation to you now. Okay. So let's go and do our next problem. Let's go and do our next problem. This is short answer questions in front of you. Okay. Let's have a look. This problem. A current of 10 ampere flows through a conductor for 2 minutes. Okay. It means a current of 10 ampere flows through a conductor for 2 minutes. Okay. So time is given as 2 minutes. Current is given as 10 ampere. Calculate the amount of charge passes through any area cross section of the conductor. So first question is, we have what is given to us? Given to us is 10 ampere of current. This is current given to us. Okay. What else is given to us? Time 2 minutes. So 2 minutes I can write. Remember, guys, this is where the student make mistake. Please do not make please don't make this mistake. Okay. So 2 minutes is nothing but 120 seconds. SI unit of time is second. So we will be doing seconds, or if required, number of hours, but minutes are never used. Okay. Now time is given as 120 seconds. We need to find how much is the amount of charge passed. So we know the formula, Q by time is equal to current. We know this, right? So Q is charge by time is equal to current. So Q is equal to current multiplied by time. Come on, calculate, give me the answer. Now let's see. So 10 multiplied by 120 This is Coulomb or C. Come on. Yes, I can see comment box. People are writing very, very nice. Good answer. 1200 Coulomb is the right answer. Whosoever has got it, very good. Yeah, but 90% I have solved, and don't be too happy now. If you really want to do something, try to do the second one by yourself. Try to do the second one. The second question says, if the charge of an electron is 1.6 into 10 to the power minus 19. Again, guys, this is a past year problem. Okay, so it is nothing. The problem is easy. All you need to know is little bit of formulas. That's it. Okay. Yes. All right. So this says, if the charge of an electron is this much, then calculate the total number of electrons. Now, how to do this problem now? How to do this problem now? We know that also. So this is one formula, guys. Okay. Q by T is equal to I, charge by time. Also, there is another formula. Q is equal to N into E. It means charge on one electron into number of electron is equal to Q. Again, I repeat, charge on one electron multiplied by number of electron is equal to total charge. All right. So just think about it. Just put it over here. Put it in formula. So what do we get over here? Q by E is equal to number. So Q we already calculated 1200. Okay. Let me just change the color of it so that, okay. So Q is 1200 divided by E is 1.6 into 10 to the power minus 19, we get N. If you calculate everything, your answer will be, yes, comment box, answer. Okay. Answer will be plus, by the way. Okay. We just have to divide 1200 divide by 1.6 into 10 to the power minus 19 and you will get the answer. Okay. So this is the answer, 1200. If you divide that, this answer will be there, 7.5 into 10 to the power 21. I hope it is absolutely clear for everybody. Yes? Yeah, give me a thumbs up if it is clear. Come on. Everybody, please give me a thumbs up. Yeah, to tell you that, to repeat that once again for all the newcomers, we have taken our first session on Friday, which was half of it. The second half is right now going on. First half we covered resistance in series, parallel, Ohm's law, electricity, potential difference, and we did few formulas over there. I explained everything in depth over there. And here we are taking the second part of the chapter, which is power and heating effect of current. Okay. And here we are doing a lot of problems along with our first part and second part all mixed together. We are doing a lot of problems also along with that. Okay. So I'm covering everything possible. So give me a thumbs up, everybody, please. And please like the video. Yeah. Please like the video also, all of you. Yeah, just request from you guys. Yeah. Thank you. All right. So Q is equal to NE. So let me give you once again those people who are still weak. Still they think, oh, current, electricity, oh my God, no, I don't know anything. No. Just a simple one. I'm just writing few formulas here for you guys. Just have a look. First formula is Q is equal to NE. Charge is equal to number of electrons. I'm just writing it here over here. Number of electrons or number of charge particles, electrons, okay, pardon my writing, okay, multiply by charge on one electron. Charge on one electron. Important question which comes in CBSE exam. Second formula, this is our first formula that we use. Second formula that we use is Q by time is equal to current. These are the two formulas related to charge. Third formula that we use is V is equal to IR or V by I is equal to R. Fourth formula we use is resistance in parallel and series. If resistance in series, we use R1 plus R2. I explained this in depth in my first lecture, guys. Please go and have that, just have a look of that video. If you do not understand what is series and parallel or you are still confused a little bit, you just watch that first lecture, watch it slowly, and you will be able to understand everything about it. I promise you that is, you will be able to understand everything about it. Please go and watch. It was done by me just few days ago. You will get that video in our YouTube channel. So this is our resistance 1, resistance 2. This is in series. If resistances are in series, this is the formula we use. Fifth formula we use is R in parallel. Guys, okay, R in parallel. Parallel, okay. All right, which is, so R equivalent is 1 by R equivalent comes out to be 1 by R1 plus 1 by R2. So these formulas are from my first lecture. Then power and heating effect. That's it. These are the formulas which are used in your entire chapter. Okay. And also one more formula is there. Work done formula. Okay. So work done is equal to, okay, I'm just writing in this box. Please understand. Work done is equal to potential multiplied by charge. Very important formula, guys. Very important. Work done is equal to potential. WD is nothing but work done is equal to V is potential multiplied by charge. So potential, writing it here, potential multiplied by charge. So these are the formulas which will be used over here. Then we have power is equal to VIP. That is P is equal to VI. P is equal to I square R. P is equal to V square by R. And then energy formula, that is heat. I square RT, VIT and V square by RT. That's it. These are the formulas which will be used in entire chapter. Okay, let's go ahead and do some more problems. Okay, now this is again a past year problem. I know everybody can do it, but I'm showing you, I'm just giving you a feel. Just feel the questions. Feel the question, how easy the questions are. So please do not skip this chapter. There are a lot of students who try to skip this chapter. Don't do that. This is an easy chapter, guys. Just very few things, 6-7 formulas, this some small numericals and stuff, and your job is done. All right. So this is define electric current and define 1 ampere. This was a problem which came. Okay. So again, I'm just showing you the answer. Electric. This is how you need to write the answer, guys. Please mug up like parrot. Just 2 months. For just 2 months here. After 2 months, you are free to go. Right. So this is electric current is the amount of charge flowing through a particular area in unit time. That's it. 1 ampere is constituted by flow of 1 coulomb of charge per second. That's it. These two definitions are very important. Okay, let's go ahead and actually hit some more problems. Okay, there's another problem which came. Name a device that you can use to maintain a potential difference between the end of a conductor. Explain the process by which this device does. So the question is, name a device that you can use to maintain a potential difference between the ends of a conductor. So what device we use? Simple, cell, right? We use cell, battery, correct? Explain the process. So there is a chemical reactions happen in the battery. Because of the chemical reaction, the electric current is produced. You just have to write in like 40-50 words. I'm sure you can manage that. So I'm just giving you a feel of it, what kind of question you will encounter in CBSE board exam. These are the kind of question you just have to write. Everybody knows in short answer questions, you just have to write 40-50 words and you're done with the problem, right? So again, this is the answer I'm showing you. A cell or a battery which can be used to maintain a potential difference between the ends of a conductor. The chemical reaction happens and then electric current is produced. You can pause this video, you can see this, you can read it through and make a notes. Keep on making the notes, guys. Whatever I'm showing you, this is the most important part. In fact, you will find the questions directly coming in CBSE board exam from these 2 lectures. You will find questions coming directly. I'm telling you this part. So everything covered over here is extremely important. So please, please, please go for it. Please study this. Please watch this video over and over again. Once, twice, thrice until you understand how to do numericals. Please watch this video again and you will find yourself getting better in your job. All right. Now let's go ahead and okay, very important question again, a graphical problem related to resistance. Now what is the problem? It says student plots VI graph for 3 samples of nicron wire. Resistances are given R1, R2, R3. Choose from the following statement. Now if you see, the graph is between I and V. V on the x-axis, V on the horizontal axis, I on vertical axis. You will find this is also a past year problem. So let me show you how to do this kind of problem first, and then we'll come back and solve this. Okay, right, let me show you this. Come on, give me a thumbs up everybody. Yeah, I'll show you how to do this problem. If you already know it, please write the answer in the comment box. If you don't know it, just be with me. You will learn in like 2 to 3 minutes from now. All right, so let's go and start this. All right, well, there will be a graph given to you guys. Okay, so graph is, let's say, VI graph. They can be IV graph also. VI graph, we are taking first VI graph. V on the vertical axis, I on the horizontal axis. Okay, so we know that from Ohm's law, V is equal to IR, or R is equal to V by I. So whenever there is a division, you see there is a division over here. Whenever there is a division on graph, you can calculate this thing by dividing y-axis by x-axis. The upper one is y-axis, guys, or the vertical axis. So this by this, or the slope on this graph will give you resistance. So what is the slope? Let's say the slope is like this. This is R1, R2. What is the slope? Slope is angle made with x-axis. So this is the slope of R1, this is the slope of R2. Let's say this is the slope of R1, this is the slope of R2. Now which one has more slope? Clearly I can see R2 is greater than R1. You can see that R2 is this much, R1 is this much, so R2 is greater than R1, clearly. So I can clearly say in this, R2 is more than R1. R2 is more than R1. This is what you have to write. That's it. I hope it is absolutely clear to everybody. So this happens in when V is vertical, I is like that. When V is vertical, I is on horizontal, we find the slope of R2, find the slope of R1, and then this is how we do the problem. Okay, whichever has more slope will be, resistance will be more. Okay, now question sometimes comes like this. I over here, V over here. In this case, let's say this is R1, this is R2. Sometimes the question comes like this. You have to be watchful what axis is what. So here, now if I find a slope, this is my slope R1, this is my slope R2 with x-axis. Now the axis has changed. Now our equality will also change. In that, here, whichever has less slope will be more, resistance will be more. Resistance will be more. So here I can clearly see R1 has less slope, so R1 will be more than R2 in this case. But this happens when, remember, I is over here, V is over here. In previous example, what I showed you, V was here, I was here. In this case, whichever is more slope, greater resistance. Greater resistance. Okay, I think it's absolutely clear to everybody. This thing is absolutely clear to everybody. This is how you will do the problem. This is how you will do the graphical problem. This graphical problem is very important, guys. Very, very important problem. Graphical problem. Okay, so let's go back to our problem. What does it say? We have I over here, V over here. So whichever has less slope, the resistance will be more. Now what is the answer over here? Come on, in my comment box, everybody. You see I over here, V over here. So I can clearly see R2 has least slope, then R1, number 2, then R3. So R2 is greater than R1 is greater than R3. So which answer matches that? Easy है ना? बहुत आसान है, नहीं? Yes, absolutely correct. Yes, those who answered answer D is absolutely right. I can see people writing answer D. Very good. Okay, those who do not know, now you know. Please remember, VI graph is the extremely important topic for exam. VI graph is like favorite examiner. Favorite. So sometime instead of giving VY, it gives you IV graph to confuse you. But I've explained this thing over there. If you see over here, if it is VI graph, this is what you need to do. If it is IV graph, this is what you need to do. All right, absolutely correct. I can see a lot of people are giving answers. Very good, guys, very good. All right, let's do our assertion and reasoning problem. Let's see. This is also a type of problem that we get in exam. Assertion and reasoning problem. Let's see. So the problem says, assertion and reasoning problem, when a battery is short circuit, the terminal voltage is 0. This is an assertion. When the battery is short circuit, the terminal voltage is 0. In short circuit, the current is 0. So I can clearly see, yes, when a battery is short circuited, the terminal voltage is 0. Yes, it is true. It is a right statement. It is true. Because when a battery is short circuit, the terminal voltage is 0. In short circuit, the current is 0. This is also true. Now both of them are true. So, okay, so I can say either answer can be A or B. Now we just need to see, is the reason good enough for assertion or not? This is an assertion, this is the reason. So you need to understand, even after knowing both of them are correct, you need to see, is reason able to explain the assertion or not? In this case, as you see, it is able to explain it. So reason is correct for assertion. All right. I hope it is clear to everybody. Yes. This is how, these are the things you need to understand, guys. All right. So here the answer over here is both the assertion and reason are correct, and the reason is the correct explanation of the assertion. Right. Okay. I hope it is clear. This is how, this is the thing that you need to focus in assertion and reasoning problems. Okay. I hope it is clear to everybody, right? Yeah, come on, give me a like over there. Give me a thumbs up. If you're liking the class, give me a thumbs up, please. Go ahead. Yeah. Everybody on the comment box, come on, give me a like over there. Let's go and do our next problem. Next problem. Okay, here the answer is A. Okay, both assertion and reason are correct. This is correct explanation. Let's do our next problem. All right. All right. So this is our second problem. What does it say? It says the resistivity of a conductor increases with the increasing of temperature. Guys, these two questions are very important in assertion and reasoning. You may have direct question coming up in exam. Okay. So you never know. You might get lucky too, right? Because these are important questions anyways. So the resistivity is the reciprocal of conductivity. So is it correct or not? See, the resistivity of a conductor increases with the increase of temperature. It is absolutely correct. Resistivity depends upon temperature. In our last class, if somebody doesn't know, please watch our last class. Please see our last class. In our last class, I explained this very well, how resistance and resistivity depends upon temperature. Okay, so this is true. Is this true? Resistivity is the reciprocal of conductivity. It is also true. But this is not explaining the assertion. This reason is not explaining the assertion over there. So over here the answer is okay. C can't be an answer, D can't be an answer. What can be the answer? Either A or B. So over here I can see reason is not good enough for assertion. So it says the assertion and the reason are correct, but the reason is not the correct explanation of the assertion. So answer B is correct. This is how you need to understand, guys, because I see many people, lot of you, even after knowing the answers, you guys do this wrong. Assertion and reason problem, you do it wrong. But please read it carefully, whether this explains this or not. Use your logic. It's a common sense, nothing else. Use your common sense, you will get it. Okay. All right. So next, let's say conductor allow current to pass through themselves. They are free charge carriers. Is it true or not? So conductor allow current to pass through. Absolutely right. Conductors, yes, conductors very well. It allows the current to pass through. It is true. I think everybody agrees with me here. Yeah. They have free charge. This is also right. But is the reason able to explain the assertion? Absolutely correct. It is able to. You see, reason conductors allow the current because they have free charge carriers. That's it. So here also both, so these two can't be an answers because both of them are true. So either one of this, both the assertion and reason are correct. The reason is the correct explanation of the assertion. This is the right answer. You can just put it. That's it. These are the things you need to remember. This is where people make mistake. All the students there where you guys actually make mistake over here. All right. So please have a look. I hope you're enjoying the class. I hope you're taking home some good points. Yes, let's go ahead and do our long answer question. Okay, let's do 1 or 2 questions. Okay. Yeah. Okay. All right. So our next question over here is, all right, VI graph here. Okay, VI graph, we can do it. I want to do another problem. Yes, this is the problem I want to do with you guys. Okay, this is 2018 CBSE problem. What does it say? Show how would you join 3 resistors, each resistance of 9 ohm, so that the equivalent resistance of the combination is 13.5 and 6. How will we join 3 resistances so that their equivalent resistance is 13.5 ohm? How will we do it? How will we join? So we have 3 resistances. Okay, just think about it. I'm just giving you a feel of the problem. Just feel it. Let's say, okay, let's keep all 3 resistance in series. Case number 1. I'm just trying to explain you guys how to do the problem, how to think. Just look at over here. Let's keep all of them are in series. So the answer is 27 ohm, which can't be an answer, right? You see, so all of them cannot be series because we want 13.5. The answer is 27. If we keep all 3 in parallel, what will be our resistance? It will be 9 by 3, that's going to be 3 ohm. You can calculate that. 1 by R1 plus 1 by R2 plus 1 by R3 is equal to R equivalent. So our answer, R equivalent will be, all right, this is like this. Okay, 1 by R1 plus 1 by R2 plus 1 by R3 is equal to 1 by R equivalent. So R equivalent is going to be 1 by 9, 1 by 9, 1 by 9. So it becomes 9 by 3 and you get 3 ohms. Now we need to see, okay, so both of them, they cannot be in series all 3. They cannot be in parallel all 3 because we want 13.5 answer and 6 ohm. How are we going to get it now? Yeah. Now let's do combination of it. Let's keep 2 of them in parallel and 1 of them in series. Let's try this. Okay, this is 9 ohm, 9 ohm and 9 ohm. Let's calculate this. So first these 2 parallel combination, let's solve this. So R equivalent for this part we are doing right now, R equivalent for this, let's calculate, is 9 into 9 by 9 plus 9. This is parallel combination. For 2 resistances we use this formula, R1 R2 divided by R1 plus R2. This is the same thing, guys. You can calculate in the same way also. It will give you the right answer. This is just a modified version of this. That's it. I'm writing you because I'm just giving you feel of it, how to do problem quickly. All right. So here we have 81 by 18. You can see 81 by 18, right? Yeah. 81 by 18. So you can divide this 9 by 2. That comes to be 4.5. And let's say this is 4.5 now. 4.5 and this one is 9. Now these 2 are in series. I can just add 9 plus 4.5, that gives me 13.5 ohm. So it means the combination looks like this. This is the right combination. It gives us the answer as 13.5. So this is how you check it. Okay, this is how you do it, this kind of problem. This thing you can do mentally. You just have to do couple of problems over here and you can do that. Yes, somebody has a doubt, you please mention your doubt in the comment box, and after this class gets over I will answer everybody personally. Please write your doubt in the comment box, right? Whosoever has doubt, please mention in the comment box. All right, yeah, it's pretty easy. Again I'm repeating, you see, question is we have to place 3 resistance in such a way that their equivalent resistance is 13.5, 6 ohm. So 13.4. So how to do this problem? I put all 3 in series. You can do this mentally. You don't have to write it. I'm writing it so that I should make you understand. But you don't have to write this. We know that series add all 3. All 3 is 27. So this can't be an right thing. All 3 parallel, divide that by 9 by 3, you will get the answer. No, it's also not right answer. Then what to do? Then just try using this kind of thing, and there we go. We got the answer. Yes? Please give me a like if you like it, if you understood it. Hit the like button over there, please. All right, let's go and do the next problem for yourself. Okay, next problem. So this is your combination. This is your first combination as we made. This is how we made two resistance in this one over here. This will give us 13.5, and if we give the resistances like this, the equivalent will be 6. Same way, just try calculating this one, please. Try calculating this way by yourself and you will get the answer. I'm leaving a homework for you guys. Answer me in the comment box after calculating this whether you got 6 ohm or not. Right? All right, guys, let's do our next problem. Let's do our next problem. I hope everybody is liking it. Yes? Let's do our next problem. Okay, thank you very much for all those likes and thumbs. Thank you very much, appreciate that. Let's go and do the next problem. Next problem is, guys, okay, now we have a problem related to electrical bulb. So electric bulb is connected to 220 volt generator. Current is this much. Find the power. Simple. What is power? VIP. Remember the formula VIP. That's it. So what is VIP? VIP. Just put is equal to in between. VIP. So what is V? V is 220. I is what? 0.5. Find the power. We can calculate, so easy. Yes, is it not? So power is equal to V into I, 220 multiplied by 0.5, and there we go. We can easily get the answer, just a multiplication. I hope everybody can do it. Yeah. Answer will be in watt. Please mention this in your exam. If you don't write the unit, your marks will be deducted. So you don't want that. All right. I will answer everybody. Whoever is asking me question in comment box, I will answer everybody. As of now, just let me complete this topic. All right. Thank you for your patience. See, okay. Now, second, okay, this is our first thing. Second thing is electrical refrigerator rated 400 watt operates 8 hours a day. Remember monkey problem? An electric refrigerator rated 400 watts operates 8 hours a day. Calculate the energy per day in kilowatt hour. How to do this? Yes, please try in your comment box. Give me an answer. Come on, everybody. Electric refrigerator. So power. So okay, first we multiply this. The answer of this is going to be 110 watt. Okay. So this is first answer. We got it. Second answer is electric refrigerator rated 400 watt. So power is given to you as 400. 8 hours per day is given to you. So it means in one day, 8 hours it runs. In one day, 8 hours runs. Okay. Rated power is 400 watt. So we need to find the energy. What will be my energy over here? Simply power multiplied by time. So what is power? 400. What is time? 8 hours a day. So what should be your answer over here, guys? Come on. Everybody. So this is 400 multiplied by 8. This comes out to be 3200 watt hour, right? Or 3.2 kilowatt hour, right? So this is 3200 watt. The same thing I can write as 3.2 kilowatt hour. This is my answer. This question is from CBSE, guys. This question was asked over there. Absolutely correct. I can see comment box, people are writing. All the students are writing the right answer. I can see that. Very well. Yes. Pretty simple. Power is equal to VI. First calculate the power. Second thing is asking you about this. Multiply power. See, is asking you about, just be little smart. Just see the smartness. Is asking about kilowatt hour. It means multiply power with time. That's it. Is right there in the answer. Is writing is giving you kilowatt hour. So what is the meaning of this? This is power, this is time. It's telling you to multiply this. You don't have to use your brain much. It's already telling you over there. Just multiply this by this, you will get the answer. That's it. And then from watt to kilowatt, everybody knows how to do it. Yes? I hope this was absolutely clear to everybody. Yeah? So, come on, give me a like button, hit likes if you like this class, then only be honest about it. I mean, if you have any if you have any comment where we can add some more thing, reduce something, please write in the comment box. All your doubts, please write in the comment box. I'll get back to you for sure. All right, and you guys are doing great. I can see a lot of guys giving right answer. You guys are doing great. Your preparations are going really nicely. Come on, go ahead. And we'll be coming up with a lot of new videos with you. Thank you very much, guys. So I'll be taking a leave now. Thank you very much. Yeah, thank you very much for your participation. Please note down, please watch this video again and the previous video. Thank you very much. I see you again. Master Teacher Ravi, sign off. Bye-bye.